To finish off our discussion on real zeros, we've seen two different situations of what a graph could do at an x-intercept. One is that a graph could touch and then turn. That happens at an even multiplicity for that factor. The other is that the graph could go through the x-axis, and that of course happens at an odd multiplicity for that factor. Okay. Now if the graph touches, then on either side of that x-intercept, your function has the same sign. They're either both positive, or I suppose if you flip that over, you could have both negative on either side of that intercept. However, if the graph goes through the intercept, then your function value is going to be positive on one side, right, that's a positive value, and negative on the other side. Okay. Now it could be reversed. You could be negative on the right and positive on the left if it's decreasing. But either way, there's going to be one number, or there's going to be numbers on one side of it that are negative and some on the other side that are positive. In fact, because polynomials never jump or have holes or anything weird like that, they're always nice smooth curves. There's a theorem called the intermediate value theorem, which basically says if you ever find a situation where function values change from negative to positive or positive to negative, then you know that in between those 2 points there's going to be an x-intercept or a real zero. Okay, and so that's very nice. And we say that if this is A and this is B, then if f of A and f of B have opposite sign, then there is a point C between A and B that is a real zero of f of x. Okay, so somewhere in there's got to be this c value that's a zero of the polynomial. Now in the case that the graph touches the x-intercept, well then you have the same sign on each side, and that doesn't really tell us much. So if I were to plug in two values, let's say a and b were here and here, that wouldn't tell us any more than if a and b were on the same side, right? Because they both, so if a and b are over here, the function output's positive for both of them, and if a and b are on either side, then the function outputs are still positive. And so it doesn't really tell us whether or not there's an intercept in between. The only time we can guarantee with a polynomial that there's an intercept in between 2 points is if one of them has a negative output and one of them has a positive output.